Examples of charging by friction, shearing, and induction. Look at question number 1. Suppose a negatively charged rock is put near the water. Charges are induced on the water molecule. Both attractive force and repulsive force exert on the water molecule. Since the distance between opposite sides of charge is smaller than that between the same side of charge, that is, D1 smaller than D2, therefore, attractive force on the water molecule is larger than the repulsive force. Hence, the water molecules will move towards the charged rock. Look at question number 2. When an insulated metal sphere carrying negative charge is touched with the finger momentarily, we say the electrons on the sphere will go through the body to the earth, and this is called earthing. Eventually, all the charges on the metal sphere will be discharged and the sphere will become neutral. Look at question number 3. When an insulated metal sphere carrying positive charges is touched by the fingers momentarily, we say earthing. In this case, electrons goes from the earth to the sphere and neutralize all the positive charges on the sphere. Finally, the sphere becomes neutral. Now look at question number 4. For part A, the charge distributions on A and B would be for part B, if A is earthed momentarily, electrons will go from the earth to neutralize all the positive charge on A. As a result, A will be charged negatively. On the other hand, if B is earthed momentarily, the electrons on B will go to the earth. As a result, the positive charge remains on B and B will be charged positively. Look at question number 5. In step 1, the charges induced on X and Y will be. For step 2, X is touched by the finger momentarily. That means X is earthed momentarily. When X is earthed, the positive charge remains there and the negative charge on Y will be earthed. After the finger is removed, X remains positive charge, but Y becomes neutral. Step 3. When X and Y are separated, X is charged positively and Y remains neutral. Step 4. Z is taken away. The charge on X is still positive and Y remains neutral. Question number 6. Assuming that the operating Van de Graaff generator, the metal dome, is charged positively, then the metal coated polystyrene ball will be induced charge on both sides. Negative and positive charge are induced. Since attractive force is greater than the repulsive force, the metal coated polystyrene ball will be attracted towards the metal dome. When the polystyrene ball touches the metal dome, sharing of charges occurs, and the polystyrene ball is charged positively. As a result, the polystyrene ball is repelled by the metal dome. Finally, the polystyrene ball remains repelled. Look at question number 7. Initial. The electroscope is charged negatively. Therefore, the gold leaf diverges. When a positively charged rod is put near the cap, more negative charge are attracted towards the cap. Therefore, the negative charges at the bottom decreases. As a result, the repulsive force between the electroscope and the gold leaf decreases. As a result, the divergence of the gold leaf will decrease. For part B, if the cap is touched by the finger, that means the electroscope is being earthed. All the negative charge on the electroscope will go through the hand to the earth. As a result, the electroscope becomes neutral. Hence, the gold leaf will collapse. Question number 8. Before X and Y are touched each other, the total charge will be plus 6Q minus 2Q, which is equal to positive 4Q. When the spheres are brought to touch each other and then separate, by the law of conservation of charges, the total charges on X and Y remains positive 4Q. Since X and Y are identical metal spheres, they share the same size of charges with the same amount. Therefore, the resultant charges on X and Y will be Qx equal to Qy equal to 4/2, which is positive 2Q.